Hello everyone, in this video we are going to talk about the 4-bit adder and simulate it in the multisim software and also have the practical demo of 4-bit adder. So let's start to talk about the 4-bit adder and see how it works. So as you can see here, you have the 4-bit adder actually is the unit which able to add two 4-bit numbers and give the result in the output. So each A and B here is the number with 4 bits. So A has 4 bit, A1 to A4. A1 is the lowest value, A4 is the highest value bit. Similar for the B. B is the 4 bit numbers, B1 is the lowest value bit, and B4 is the highest value. So if you want to add A and B, each one is 4 bit, definitely result could be 5 bit. So that's the reason you see 5 output in 4-bit adder. So the first 4 is S1 to S4 and the fifth bit you usually represent with C4. So that means these units able to add these A and B and give the result in S1 to S3, and if you produce the carry, you keep that fifth bit inside the C4. You have another input which is C0. Usually C0 add with these lowest value bits, so that means S1 is B1 plus A1 plus C0. So in some application, especially whenever you want to extend these 4-bit adder and make the bigger bit adder, so usually this input is useful. So also if you don't like to use that, just connect this to the 0, which is don't affect your 4-bit adder. So the IC that we have for 4-bit adder is 7483. So let's have the small simulation and see how you could simulate this 4-bit adder. So before I start to take a look at the simulation, let's take a look to the pin of 74LS83, which is 4-bit adder. So you could identify the same inputs and outputs that I mentioned in the beginning of this video. So as you can see, pin 1 to 10 is your A1 to A4, pin 16, 4, 7, 11 is your B1 to B4, pin 13 is your C0, pin 14 is the output, C4, and pin 9, 6, 2, and 15 in these IC is your S1 to S4. So because these are the outputs, we actually connect these to the indicator, to the LEDs, and see what is the result. So let I just adjust the simulation a little bit that you're able to see the whole circuit here. So let's just, yep, this one is good. So as you can see here, what we did, we connect the A1 to A4 to the 4 switch. One side of this switch connected to the VCC, which is 1, and other side connected to the ground, which give you a 0. So that means whenever I switch between these two, or open or close switch, I'm able to give 1 and 0 for each of these inputs that I have. So here I have A0 to A3, and also B0 to B3, which is give the 4 digit for the B and the A. I connect the C0 to the another switch, which I able to give 0 to 1 to this C0 that I have. And the outputs all connected to the indicator. This one is C4 and this is CS3 to 1 and 0. So let's start to simulation, and maybe it is better to start with put everything on the 0, then start from that point. So I put everything on just to see which one is 0. So yeah, they should be somehow put all of them down, which is the 0. So right now I'm making the all inputs 0, which is right now is 0, and the C0 is 0. So right now you have 0 plus 0, which is everything is 0. The output should be 0. This is A0. If I close that, I give 1. So I have 1 plus 0 should be just 1. So if I add 2 here, which is I give these 1 and 1, which is 3. So that means I have 3 for A, this is 0. So 3 plus 0 is 3. So you have 3. So here I close this one. Right now I have 1, 1, 1, which is 7, and this is still is 0. 7 plus 0, you have 7. So let I add this one too. Right now I have 4, 1 for A, which is 15, and this is still is 0, so you have 0 here. So you could actually test the same thing for the B and make sure the circuit works. So here, so see, this is actually 8. It's actually close 8. If I close this, you have 4. This should be 2. This is right, and this is 1. So that means A is 0. This is 1. You have 1. So you could have more fun. So see, let I just give 1 for A. So which is you have 1 plus 0. It again is 1. So right now let's put the B is 1. So that means right now I have 1 plus 1 should be 2, which is right. This is 0, 0, 1, 0, which is 2. That's right. So I have 2. Let I add another 2. I should get 4. That's right. So right now I have 4. So let's add another 2 here. So you should get 6, which is right. So I have 6. Let's add another 4. Should be give you a 10, right? 8, 2 is 10. So right now you are on 10. Let's add 1, 8. So we should have 18, right? So this is 16, this is 2, and you have 18. So you could actually test for all other numbers. So if you test for any number, so definitely the result is this A and plus B. So let's move to the practical demo and implement the same circuit in breadboard with 7483 IC and see it works or not. So let's check the practical demo. So here I have one 7483 and we make the circuit exactly based on what we saw in the simulation. So here this is my test bench, which I explained in our first video. If you don't know what is this test bench, please check our previous video which we explain how you could make that. So here I have 4 switch, which is I able to give B. So this 4 switch that you see on my right, this one is B4, this is B3, this is B1 and B0. Sorry, B4, 3, 2, 1. We start with 1, 2, 4. Okay. So this one is the highest value and this one is lowest value. Similar thing for the A. So this 4 is A, this one is A4, and this one is A1. So that means we have with 4 switch you are able to give A, and with other 4 switch you are able to give B. So because here we have the limitation in the switch, we couldn't actually put the C0 in the other switch. For that reason, we just connect the C0 to the ground. So if you have more switch, definitely you could add one more switch and able to give 0, 1 to C0. For here, we just connect the C0 to the ground. This 4 is A and this 4 is B. Let's test it. So as I mentioned, this is the highest value bit. So if you check your output port, so here you have the carry. So that means whatever you see here on the middle light is C4. Then you have S4, S2, S1, and S0. So that means the LED that you have in this right side is the highest value, and whatever you have in my left is the lowest value. So for example, right now everything is on 0, so this is B4. If I just turn B4, so definitely I will have 8. A is 0, B is 8. So that means 0 plus 8 is actually 8. So that's the reason you see this is 0, 1, 1, 2, 3, 0, which is 8. So if I add another 8, I should get 16, right? So that means this should be jump here, right? That means the C4 should be 1, the rest 4 should be 0. Let's do that. This is A is 8. Let's put the B as actually 1, 8, A plus 8, 16. So as you can see, this is off and C4 is 1. So right now I have 1, 4, 0, which is definitely 16, okay? So let's just put these back to the 0 case and few in the A. So right now this should be 8, which is right. So if I add 4, so the B is 0. Right now A is 8 plus 4. You have actually 1 1 0 0, which is right. If I add 2, so you see 2 is on, so this is right. And if I have 1, definitely should be 15, so which you see 15 here. Okay, so now this is 15. Let to add with 1, so you have 16. Let's see 16. So you have 16. Let to add 2 here from B2, so you should have 18. So see 16 plus 2 is 18. So you could add 1 more, 4, right? And also you could actually have 15 plus, sorry, let to do this. Let to have this one, which is we have 15, right? We have, this is 15, right? So then we actually have, get to see what we have currently. This is 15, right? So then we have these 15 plus 1 is 16, that's right. We have 2 is 18, and we have 4 is 22. Okay, 22. So here we have 16 plus 4 is 20, and this is 2 is 22. Okay, so as you could see, you could actually test that for different numbers, and definitely for all of them you should be able to works. So currently this is 0, this is 15. Again, you could able to see 50. So this is how the practical demo works on the breadboard. I hope you like this video. Thank you for watching.